Hi, my name is Alireza. I'm a faculty member at the University of Tehran. The topic that I'm going to talk about is assessment of energy storage technologies in the smart grid by using a hype cycle diagram. So, electricity plays a crucial role in the energy supply of countries. Therefore, countries' economy, national security, and the health and safety of residents depends on the reliable and affordable delivery of electricity. The fact is that the electric grid in a country is a complex system and is more than just generation and transmission infrastructures. They create an ecosystem of assets owners, manufacturers, service providers, and government officials at different levels. So with development of new technologies and utilization of renewable energy resources, modernizing the electric grid system is necessary for countries. This means they should be more smarter and resilient. So a smart grid includes different components from different levels, from new and renewable energy sources, managing loads to create grid visibility, with the creation of automated remote control centers that reduce the number of grid outages by creating the system's healing are some examples of these smart grid components. One component that has a strategic role in a smart grid is storage technologies. Creating a balance in the electricity grid through energy storage will lead to the separation of production time from consumption. Moreover, this leads to better stability of the transmission and distribution grid, and the overall security of the system will be increased. Energy storage systems allows the production and distribution of electricity at its highest capacity, which reduces the demand for new production and distribution lines. Energy storage technologies provide a variety of services in different locations and throughout the grid. The key application of these technologies are as you can see from this figure. For example, the seasonal energy storage technologies can store energy for a day, week, and month, and use the stored energy in distribution in a power supply or by changing supply and demand of the energy system in the seasons. This slide shows different energy storage core technologies in the smart grids. Of course, they all have their subsystems technologies. For example, just mentioning one example, the pumped storage hydropower. The water is pumped from the lower tank to the higher reservoir, and thus the electrical energy is stored as potential energy in the pump water in the higher altitude. Among thousands of technologies that are being developed every year, few of them have chance to be successful in the market. Assessment of technologies can help to reduce the risks of the technology development and provide the information the technology developers, investors, or policymakers require in order to avoid the failure of the technology and increase the success rate of those technologies. This is a means we can understand how new technology can be developed from the time when it was first developed to the time when it is potentially accepted by the public and authorities for the future. It's a way of trying to forecast and prepare for the upcoming technological advances and their repercussion to the society, and then make discussion based on the judgments. This picture shows that how technology assessment is a rich field of study in healthcare studies. So we can see that there are different tools that can be used, for example, as a technology assessment tools in the healthcare studies. However, in the field of energy and environmental studies, it's a quite new field, actually, technology assessment, and the most concentrates of the technology assessment and using technology assessment tools in energy and environmental studies are just focusing on life cycle assessment, techno-economic assessment, or social economic assessment. However, we have a variety and different kinds of the technology assessment tools that can be used in our field, I mean energy and environmental sciences. So the purpose of this research is to investigate and map the situation of each energy storage technologies and their sub-technologies in one of the recently developed technology assessment tools, hype cycle diagrams. This is one of the new tools that we can use for diffusion and adaptation of a new technology in the markets and the social and we can show the social acceptance of the technology by using the hype cycle diagram. It has been developed by the Gartner Group. So the hype cycle diagram shows the maturity, adoption, and social applications of specific technologies. So hype cycle provides a graphic representations of new maturity and adoption of technologies and applications and how they are potentially relevant to solving real business problems and exploiting new opportunities. Gartner hype cycle methodology gives us a view of how a technology or application will evolve over time, providing a sound source of insight to manage its deployment within the context of our specific business goal. So this figure shows different stages of the hype cycle diagrams. The first stage is the technology trigger. So it is a kind of a potential technology breakthrough to kick off things off. Early proof of concept stories and media interest trigger significant publicity. Often no usable products exist and commercial visibility is unproven. The second stage is the peak of inflated expectations. Early publicity produces a number of success stories, often accompanied by scores of failures. Some companies take action, many do not. The third stage is truth of disillusionment. Interest waves as experiments and implementation fail to deliver. So producers of a technology shake out or fail. Investment continue only if the surviving providers improve their products to the satisfaction of early adopters. The fourth stage is the slope of alignment. So more instances of how the technology can benefit the enterprises start to crystallize and become more widely understood. Second and third generation products appear from technology providers. More enterprises found pilots and conservative companies remain cautious. And the last stage is the plateau of productivity. Mainstream adaptation starts to take off. Criteria for assessing providers' viability are more clearly defined, and the technology's broad market, applicability and relevance are clearly paying off. So this slide shows the methodology that we have used for this research. We have two different steps in order to identify the situation of each energy storage technologies and their sub-technologies in the hype cycle diagram. So we can say that the hype cycle diagram is the combination of the life cycle diagram that you can see here in the right side and the adoption diagram, which you can see here in the left side. So first we illustrate the technology tree of the energy storage. And after that, by searching the patents in some valid sources, US patent and EU patents, and finding the title of each patent by using the Google patent, we found that the situation of each patent and the situation of each technology in the life cycle diagram. And by using the Google trend and its advanced application, we found the situation of each technology in the acceptance diagram, which is it in the early adopters or late maturity? So you can see that we have considered both aspects of the R&D aspects and technology development aspects and technology awareness, technology adoptions, and these kinds of issues in our research. After that, when we found the situation of each technology in both diagrams, easily the situation of the technology in the hype cycle diagram can be identified. In order to verify our results, We use two different kinds of the models for validations of our research by using the TRL and interviewing with three experts in the field of the energy storage around the world, from the Canada and from Iran. So we assure that our model, it was confirmed. So here you can see our research results. As it's noticeable, the congestion of the technologies is in the peak of inflated expectation stage. This can be justified by the early stage of smart grid storage concepts and sub-technologies in the academic and industry. However, with the current development of technologies like sodium sulfur battery and hydrogen storage, the expectation would shift to the disillusionment storage. In contrast, the lithium-ion battery and storage sub-technologies like turbine are in the R&D and market acceptance stage, as you can see here. One of the important steps in the hype analysis is the verification of the result. We verify our result with two different sources. First, comparing the outputs with technology development, technology readiness level or TRL of each technology. Then the verification is conducted through experts' opinion, as I explained in the methodology part, by showing the results and collecting their views about the situation of each technology in each diagram. So thank you very much for your attention and your interest. If you have any question, please let me know by the following email. Thank you very much and have a nice